We're about to start Chapter 2. Chapter 2 is all about transformations of functions. Transformations are things like stretches and compressions, and translations, moving up and down and to the left and to the right. But before we talk about translations of functions, I want to introduce you to a new type of function. I want to talk about rational expressions. Rational expressions are quotients. Quotient means divide. Divide two polynomials. And we usually write this new function as f of x. Our function is actually two functions, p of x and q of x, put on top of each other, as long as the function on the bottom does not equal 0. When you divide by 0, no dividing by 0, it's undefined. Undefined means it could be anything. It could be a very large positive number, it could be a medium-sized number, it could be 0, it could be a negative number. Dividing by 0 is not done because it gives us no information. That's what it's saying here. Rational expressions must be checked for restrictions by determining where the denominator is 0. These restrictions have to be stated when the expression is simplified. Every time you have a rational expression, when you have a polynomial, something with x on the bottom, you have to state what x cannot be. You have to state what values of x make the denominator 0 so that who's ever using this function knows to avoid them. Let's give it an example. So what are we going to do? Here we have one of our new rational expressions. We have a polynomial, it's a 1, 2, 3, it's a trinomial on the top, and it's a binomial on the bottom. We're going to simplify each expression and determine any restrictions on the variable. What do I mean by simplify? Simplify, factor. Hopefully we're first going to factor, and then hopefully we're going to be able to do something next. So we need a factor. All right. What are we going to factor? Well, here's our f of x. Is this equation? The whole equation, both the top and the bottom. That means our p of x, our numerator, is x squared plus 10x plus 21. So if I'm factoring, I need two numbers, and I'm going to show you a little trick. We need two numbers that multiply to 21 and add to 10. Two numbers multiply to 21 and add to 10, they got to be 3 and 7. So what am I going to do with my 3 and 7? I'm going to put x plus 3, positive 3, so that's one of my x-intercepts. And my other one is x plus 7. Now I'm going to look at my q of x. So the numerator has been factored. Can we do anything to simplify that? Nope. It stays as is. That means overall we have x plus 3, x plus 7 over x plus 3. Well, top and the bottom are exactly the same. If top and bottom are the same, they can get canceled out. It's like multiplying by something and then dividing by that same something. You've just undone all your work. You may as well not even go in a circle like that. Not done at all. F of x is 7 with x plus 7. For restrictions, so now we have our simplified expression. Wonderful. Next is restrictions. Sorry about that. For restrictions, to do the restrictions, I need to look at my denominator, my q of x. That was x plus 3. And I know that for my restrictions, the denominator cannot equal, that's an equal sign that's been broken by a line, cannot equal 0. So I have x plus 3 cannot equal 0. I can treat that does not equal sign, if you will, just the same way I would treat an equal sign in an algebraic expression. I'm going to go x cannot equal negative 3. I brought the positive 3 around to the side. So I use this restriction over here. My final answer, let's write at the bottom, f of x equals x plus 7, but x cannot equal negative 3. All right. Cool. So I have simplified the expression and determined the restrictions on the variable. Go to example 2. Let me see if I can get the light up a little bit. Oh, okay. For example 2, we have one numerator. I'm going to call my numerator p of q, p of x, excuse me. I'm going to call my denominator something else. I'm going to call my denominator q of x. Why am I doing this? Mostly because I need some way of keeping track of each while I split them up. You can keep everything together. I find I get a little lost about which number goes where. Let's do p of x first. P of x equals 6x squared minus 7x minus 5. First thing I'm going to check, is there anything that I can divide all 3 terms by and still get a whole number? Nope, nothing. All right, fine. That's okay. I've got a new trick that I can use. I'm looking for 2 numbers that multiply negative 30. That's a times c. And it's got to add negative 7. So what are 2 numbers that multiply to negative 30 and add to negative 7? Well, 10 and 3, it's going to be negative 7. It's going to be negative 10 and positive 3. I'm going to take my 6. That 6 is going to become a numerator. I'm going to write 6x up here. I'm going to write 6x up here. This is just a trick that I know that will save me some time for factoring. If I simplify this, 6 over 10, what does that simplify to? Well, I can divide both of them by 2 and I get same as 3x over 5. This was negative, this stays negative. Here, 6x over 3 can simplify as 2x over 1. Divide both the top and the bottom by 3. Why did I do all that? I now know my bracket. My first bracket is going to be 3x minus 5. And here's my second bracket, 2x plus 1. Saves me a lot of work for factoring. Let's do q. Q of x is 3x squared plus 10, plus x minus 10. Sorry about that. So I'm looking for 2 numbers that multiply negative 30 again. So this time they got to add to positive 1. 2 numbers that add to 1 but multiply to 30. Oops, sorry, getting a little low. Numbers that add to 1 and multiply to 30, probably 5 and 6. It's got to be positive, and the 6 has to be positive, and the 5 got to be negative. I'm going to take my 3, put it on top with an x. Now my 2 numbers are 1x over 2, and my other side is 3x over negative 5. So does that make my factors? Therefore, g of x is x plus 2 and 3x minus 5. So what's my final? My f of x, my total. F of x, the original function way at the top of the page. My original function was the same as what I called p of x over what I called g of x. P of x ended up being 3x minus 5 times 2x plus 1 all over g of x plus 2, 3x minus 5. We can see that we've got 2 of the same terms. These can be canceled. And so my f of x is the same as 2x plus 1 over x plus 2. Now we got to do restrictions. So how are we going to figure out the restrictions on this? So for a restriction, let's do it at the back of the sheet. We got to look. Q of x cannot equal 0. What was q of x when we simplified it out? X plus 2. 3x minus 5. Both of those cannot equal 0. So these are two things multiplied together. That means that this by itself cannot equal 0, or this, or 3x minus 5 cannot equal 0. If this part equals 0, then no matter what I multiply it over here, my answer is going to be 0. If this bracket ends up being 0, then no matter what I multiply it over here, it's still going to be 0. So both of these have to be checked. So algebra time. X does not equal negative 2. 3x does not equal positive 5. So x cannot equal 5 over 3. So these are my two restrictions, negative 2 and 5 over 3. So x cannot equal negative 2, and it cannot equal 5 over 3. So you make a list over there. So here's my final answer. F of x equals the simplified one from before, and my two restrictions. So next one, determine whether the function in each pairs are equivalent. Okay, so let's go back to our top of the previous page. We know to determine if two expressions are equivalent, you have to simplify both to see if they are algebraically the same. So simplify. All right. So let's start with f of x. Here we go. F of x is equal to 2 times x minus 1, and it's squared, so that means 2 of those, plus 3x minus 2. Okay. Well, so simplify. We've got one bit over here, and we got more x's over here. So what I'm going to do is I'm going to FOIL to get an expanded version of this, and then I'm going to combine like terms and hopefully get this to look a little neater. I'm going to get 2x squared minus x plus 1. And see how there's nothing in front of this bracket, just a plus sign? This bracket I can just make go away. If there was something in front, then I'd have to distribute that to each of the terms inside the bracket. We're going to end up with 2 times x squared minus 2x plus 1 plus 3x minus 2. Let's distribute the 2. 2x squared minus 4x plus 2 plus 3x minus 2. All right, 2x squared, 4 and 3, negative 4 plus 3 minus x. 2 and 2 is 0. F of x is 2x squared minus x. What's g of x? What we're trying to compare it to. 2x squared minus x. So this is what I mean by compare algebraically. Are these two the same? Well, they've got the same coefficients in front of the x term. They've got the same coefficient in front of the x. All right. Therefore, they are equivalent. Hey guys.